Hey guys, here are your day one notes for section 6.6. Section 6.6 is the last section in chapter 6. So once we're done with this, we'll do this section this week, and then next week we'll take either a chapter 6 test, or I'll just test you on 6.4 to 6.6 because we already did 6.1 to 6.3 in our first quiz. All right, but either way, this is the last type of graphing transformations. This is going to be a phase shift. So right now, in the previous sections, we have vertically stretched or shrunk a trig graph. We have horizontally shrunk or stretched a trig graph. And then we saw in the last section that we finally did a vertical shift. We bumped it up or down so many units. So the only type of transformation that we have left is your phase shift, which is shifting your trig graph to the right so many units or to the left so many units. So it's kind of like a slide or a translation, if you will. All right. So we're going to focus on the sine and the cosine with these transformations. So let's just remember what we know about y equals sine x and y equals cosine x, the original trig graphs of sine and cosine. So I've given you their graphs. All right. So the sine graph, the cycle, his first complete wave, which is from here to here, right? It takes 2 pi units to create one sine wave. It starts at an x value of 0, and the cycle ends at an x value of 2 pi. That's going to be important, okay? That's his period, his first cycle. The period is 2 pi radians. And the amplitude, half the distance between the highest and lowest point, right? That it's kind of like so many units up and down from that midline, was 1 unit. Okay, and then the cosine, it took 2 pi radians to create one of his first waves, his complete cycle, right? So one complete cosine wave went from 0 to 2 pi, and it looked like that. So again, his cycle also starts at an x value of 0, and it ends at an x value of 2 pi. So both of these graphs start at the same x value and they end at the same x value during their first cycle. All right, his period is also 2 pi radians. And the amplitude is also 1. It's 1 unit up and 1 unit down from that midline, right? Half the distance between the highest and lowest point is 1 unit. Okay, so what we're going to do is we're going to graph sinusoidal functions, which is a transformation of the sine graph, which again, the cosine is said to be just a transformation of the sine graph anyway, right? We can see the sine wave on the cosine's wave as well. Okay, so what they're going to do to make you pull out and recognize these transformations, they're going to make you like rewrite the function. So let me just practice something with you really, really quick. So guys, if I gave you the expression 2x plus 4, if I asked you to pull out the leading coefficient, let's say I asked you to factor out the 2, right? Your leading coefficient. We would rewrite this as 2 times, what happens when you pull out a factor of 2? You divide these by 2. So 2x divided by 2 is x, 4 divided by 2 is 2. So then it becomes this expression, right? I've pulled out the leading coefficient. And if I multiplied them back in, 2x, 2 times 2, I would get back to the original expression. They're going to make you factor out the leading coefficient inside the parentheses so you can recognize your horizontal stretch or shrink, and then you can recognize your phase shift. So just get ready for this. So it's not always going to be pretty. So let's look at this one. If I asked you to factor out the leading coefficient, I'd have to factor out a 3. So then I would pull the 3 out, and then that would leave me with what? Divide this by 3, x. Divide this by 3, and you would be left with negative 5/3. So it's going to look weird to pull out the leading coefficient because, again, we're not necessarily pulling out the GCF. We are pulling out the leading coefficient. But if I multiplied 3 back in, 3 times x gets me 3x. 3 times negative 5/3 is negative 5. Oh, good. Thanks, bud.
Is that good?
Yeah, thank you. I appreciate it. Thanks, bud. All right, so 3 times x is 3x. 3 times negative 5/3 would get you negative 5. So you're going to have some weird expressions like this, so just get used to it. So look here. If you had the expression pi x plus 2, right, you have to pull out the leading coefficient of pi. So you would pull out the pi, and then you would divide this by pi. I would get x. Divide this by pi, and you would get 2 over pi. And that would be your new expression. So this would be causing your horizontal stretch or shrink, and then this one would be your phase shift. So pi times x gets you pi x, pi times 2 over pi, the pi's cancel and gets you back to 2. So get used to this because you're going to have to rewrite the original function by pulling out that leading coefficient so we can recognize what the phase shift is going to be. Okay, all right, so here we go. So we are going to graph transformations of sines and cosine functions that are going to be in this form. Y equals a times the sine of omega x minus, this is the Greek letter phi, P-H-I, and then plus beta. Or y equals a times the cosine of omega times x minus phi, and then plus beta. So all of these Greek letters represent some sort of transformation. Now, some we should recognize because we've already done and what cause they're going to have on the graph. And then the phi is going to be new. He's going to be your phase shift. So the first thing they're going to want you to do is to rewrite your parentheses by pulling out omega, pulling out that leading coefficient so you can recognize what your phase shift is going to be. So you're going to rewrite this one as y equals a times the sine of, pull out omega, and then what's left? If I divide this by omega, I have x. Divide this by omega, and I have minus phi over omega. Right? So now you can recognize that the omega is going to be times by your x's, so he's going to cause some type of horizontal stretch or shrink, and then you're going to be minusing or adding this phi over omega, so he's going to be your phase shift. He's going to be how many units to the right or how many units to the left you slide this graph, okay? All right, then you're going to rewrite this one as y equals a times the cosine of, we want to rewrite this by pulling out omega. So it'll be omega times, divide this by omega, I get x, divide this by omega, and I get negative phi over omega, and then plus, oh, I forgot that, plus beta is still on the outside. All right, so again, you have to rewrite inside your parentheses by pulling out that leading coefficient so you can see the separate phase shift, okay? All right, so what's going to happen? A is on the outside, so he's going to times your y's by a, which means he's also going to multiply your amplitude by a. So your amplitude should be a positive number, so it's going to be the absolute value of a times the original amplitude of these graphs was 1, so it's going to be the absolute value of A. So whatever this front number is, the absolute value of it is going to represent your amplitude, what the highest and lowest value the graph reaches is going to be now. All right, your period, they call it T. Your period T is going to be, well, think about it. It's omega times x, right? Omega times x, even when you put it back in. So if you're timesing your x's by omega, then in reality, the opposite of that is happening, and your x's are getting divided by omega, and that's causing that horizontal stretch or shrink. So that whatever you did to your x's, whether you divided your x's or multiplied them, you're doing the exact same thing to your period. So your period used to be 2 pi units, but now you're going to take 2 pi and divide it by omega, and that's going to get you your new period of this transformed graph. All right, and then your vertical shift is just going to be, oh, I should go over here. Your phase shift, your horizontal shift is going to be, well, if you have x minus phi over omega, then really the opposite of that would be happening, and you would be shifting to the right phi over omega. But your phase shift is going to be phi over omega units. All right, to the right or the left. And then your vertical shift is going to be coming from this plus b, because you're going to be adding it to your y's on the outside. So your vertical shift is going to be plus that beta, that b value. All right, again, it's always hard to look at it in terms of letters. It'll be a little bit easier when you actually see it with numbers that are used in an equation. All right, so for example, here's just a example of a sine graph that used to start at 0, 0, but now he's been phase shifted phi over omega units to the right, and now it takes phi over omega plus his new period to create that new sine wave, okay? All right, let's try one. All right, so it says, find the amplitude, the period, and the phase shift of y equals 3 times the sine of 2x minus pi, and then graph the function. All right, well, the first thing we need to do is, I'm gonna get a piece of paper because I'm gonna need a lot of room for this. Let me rewrite it. It's gonna be y equals 3 times the sine of 2x minus pi, right? Okay, so the first thing you need to do is rewrite it by pulling out that factor of 2. So we're gonna rewrite as y equals 3 times the sine of, pull out the 2, and then what's left? If I divide this by 2, I have x left. If I divide this by 2, I have minus pi over 2. And then there was no plus number, so there's no vertical shift up or down here. Okay, so this is what we're actually going to be graphing. So if you look at it, this 3 on the outside, that's 3 times the y's. This 2 on the inside, that's 2 times the x's. So really that's x divided by 2. And then really this x minus pi over 2, that's your phase shift. If it says to take the x's and minus pi over 2 units, remember the opposite of that happening, and we're going to add pi over 2 units. So it's going to phase shift the graph pi over 2 units to the right. All right, so let's take that in steps. So the first thing I'm going to do is, because we're going to deal with our x coordinates first, let's identify the changes to the x. So right now, clear as day, it said 2 times x, and it still says 2 times x when I throw it back in. So if the equation says 2 times x, then really that's going to be the x's getting divided by 2. All right, so we're going to take all the original x coordinates on his first curve, his first cycle, and we're going to divide all the x's by 2, which means if your x's got divided by 2, so did your period. So your period got divided by 2 as well. Well, our period used to be who? 2 pi. We've now divided it by 2, which means your new period is going to be pi radians. That's your new period. It's only going to take pi units to create one sine wave now. Now, if you want to get yourself set up, we know it's all about those key points and those subintervals. So if you take the new period pi and you divide it by 4 sub-intervals that we're going to create, that's going to make pi over 4. So pi over 4 is going to be your counting increment. Okay, so if you wanted to, you could go to your graph right now and start counting along your x-axis by increments of pi over 4. So watch this. This would be 1 pi over 4. 2 pi over 4 reduces to pi over 2. This would be 3 pi over 4. 4 pi over 4 would be pi. 5 pi over 4. 6 pi over 4 reduces to 3 pi over 2. 7 pi over 4. 8 pi over 4 is 2 pi. 9 pi over 4. 10 pi over 4 is 5 pi over 2. And then you could probably stop because you don't probably need all of the lines. And then you could count negative by pi over 4. This would be negative 1 pi over 4. Really, you should just be copying these in the negative direction. Then it would be negative pi over 2. Then it would be negative 3 pi over 4. Negative pi. Negative 5 pi over 4, and then negative 3 pi over 2. And now your x-axis should already be ready for your new ordered pairs that you're going to create by these transformations. So I like to do that and get myself ready. Okay, let's go back. Okay, so now there's also going to be your x's. It looks like you're subtracting pi over 2 from them, but we know the opposite happens. So that's going to be your x's are going to add pi over 2, which is going to shift right the whole graph to the right pi over 2 units. Okay? All right, so that's what's happening to x. Now, when you add or subtract to the x values, that doesn't affect the period. Only dividing or multiplying the x's affects the period. So your period only gets changed by what you did to the x's by multiplying or dividing. All right, now what's happening to the y's? Only one thing is happening to the y's. It's 3 times the y values. So that's going to be 3 times the y's, so your y values are going to get 3 times as big. Now remember, whenever you multiply or divide the y's by, that affects the amplitude. So this is also 3 times the amplitude. So that's going to be, the amplitude is going to equal the absolute value, because it has to be a positive number, of 3 times the original amplitude, which was 1, and that's going to be the absolute value of 3. Your new amplitude should be 3 units. All right, so it should be 3 units up and 3 units down from that midline. All right, here we go. So if you remember the original graph of sine, right? It's going to be y equals the sine of x. He was the mom and dad, right? He had a period of 2 pi units. He went up 1 and then down to -1. His original graph looked like this. Right? That was the original sine wave. So he went from 0 to 2 pi. When you took his period 2 pi and divided it by 4, we were counting by increments of pi over 2. Every pi over 2 units, there was some key point, right? Here, 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 and then here. These were his 5 key points that lived on his graph. So his 5 key points were 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and then 2 pi brought us back to 0. Okay, so those were his 5 key points. Now we're going to make these transformations to them. Okay, so the first thing we're going to do is take his x-coordinate 0. We're going to divide it by 2, which is still 0, and then we're going to add pi over 2 to him. So then 0 divided by 2 is 0. 0 plus pi over 2, it moves his first point to pi over 2. Okay? All right, and then we'll finish them and then we'll graph them. All right, now you're 0. You're going to take your y-coordinate 0, and the only thing you have to do to the y's is times it by 3. So 0 times 3 is still 0. So that's the first point on the transformed graph. His first cycle is going to start at a unit of x value of pi over 2. All right, let's go to the next one. Okay, so now we're going to take our pi over 2. We're going to divide him by 2. So we're going to take pi over 2, and we're going to divide him by 2, which in reality becomes pi over 4. All right, so we took pi over 2, we divided him by 2, we got pi over 4. Now we have to add pi over 2 units to him, because there's 2 changes happening to x. So now you're going to add pi over 2 to him. Okay, so if we add pi over 2, well, think of this. This is what? 2 pi's over 4. So that's going to be 3 pi over 4. So your next x value is 3 pi over 4. And again, we got that by dividing this by 2 and adding pi over 2 to him. All right, now we take our y and we times it by 3. So 1 times 3 is 3. So that's a new point on the transformed graph. All right, here we go, pi. We're going to take our x value. First, we're going to divide it by 2. So we're going to take pi, divide it by 2, which is now pi over 2. And then we're going to add pi over 2 to him. Well, guys, that's going to be 2 pi's over 2, which is pi. So now your next x value on your transformed graph is going to be pi. So again, the shifting and the shrinking, it kind of brought him back to where it needed to be, and that's fine. Don't worry about it. All right, now we take our x value, 0, and we times it by 3, which is 0. Okay, now we go to the next one. We're going to go 3 pi over 2. Take your x value. 3 pi over 2, and first we have to divide him by 2, which also means dividing him by 2 times him by a half, which is going to get us 3 pi over 4. Now we take that and we add pi over 2 to him, okay? So now plus pi over 2. Well, remember, this is 2 pi's over 4. So 2 pi's over 4 plus 3 pi's over 4, that's 5 pi over 4. So your next x value is 5 pi over 4. All right, take your y value -1 and you're going to times it by 3. So that's -3. Okay, now we're going to take our last x value and make it the appropriate transformations. So take 2 pi, the original x, and divide him by 2. And now you get pi. Now you have to take pi and add pi over 2 to him. Okay, well, this is 2 pi's over 2 plus 1 pi over 2. That's 3 pi's over 2. All right, so your next x value is 3 pi over 2. Take your y value, 0, and times them by 3. So it's still 0. So now these are the first 5 key points on your transformed graph. So if you go to your graph, we already kind of have it ready. This is what his graph is going to look like. 1, 2, 3, -1, -2, -3. All right, here we go. So our first transformed point went from 0, 0 to this. Pi over 2, 0 is the first point on your transformed graph, and we were ready for him. We had our x values up. Your next point got shifted to 3 pi over 4, 3. So now we're going to go to 3 pi over 4, 3. So by us doing this, our x values are ready to go. All right, our next transformed point went from pi over 0 to pi over 0. And again, that's just because of the stretching and the shrinking that caused him to actually kind of come back home where he started. All right, your next transformed point went from here to here. So 5 pi over 4, -3. All right, and then your last transformed point went from 2 pi 0 to 3 pi over 2, 0. And now this is what it looks like to create that first sine wave on your transformed graph. He has been vertically stretched, he has been horizontally shrunk, and shifted to the right pi over 2 units. All right, and again, now just by the pattern, you could continue it again. So 0 came out, 3 would come out next, then 0 would come out, then -3 would come out, and then you'd be back to 0. And there's another cycle of your transformed sine wave. And then you could just do it like that. Now again, luckily you have the online graphing tool, so you won't be graphing anything on your own. You're just going to be putting in what the changes are. You're going to be putting in this horizontal stretch or shrink, this horizontal phase shift to the right pi over 2 units, and then this vertical stretch by a factor of 3 and whatnot. All right, just be careful. A lot of times, even though this caused a horizontal, I would say, shrink by a factor of 1/2, it's looking for the 2 though. So it's going to be a horizontal shrink by a factor of 2. They want the original value as it was in the equation when you go to put it in one of those little gray boxes that pops up. All right, I'm going to do the back on the next video. So I'll be right back. Oh, just really quick. So just to kind of mark everything, your new amplitude, as we said, is 3. Your new period, which they call t, is, what did we say our new period was? We took the old one, divided it by 2. Our new period was pi radians. And again, it took pi radians from pi over 2 to 3 pi over 2. That's a distance of 2 pi's over 2, which is pi units in between to cause one sine wave. All right, and then your phase shift is, where is it? Pi over 2 units. You are shifting to the right pi over 2 units. And that's the information they asked you to find here, okay? All right, I'll do the next one on the next video, or the back of the page.